Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 4H. Myself, Shashwat Mani Tripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start the session, I would like to introduce you to the chair of this session, Dr. Rupali Mahesh Chopade. Ma'am is an associate professor at DES Pune University, Pune, India. Her area of expertise include database, forensic, machine learning, data recovery, instruction detection system, and NoSQL database with a strong focus on data security and intelligence system. Dr. Chopade continued to contribute to advanced research in innovation teaching in the field of computer science. Now, I would like to start the paper. Shilpi Taneja, paper title A Low Code, No Code Approach to Design Open Source AI Powered Learning Assistant. The next we have Anupma, paper titled Advance in Passive Self Balancing for Electric Vehicle Battery Management System.
Hello, hello, am I audible?
Yes, Anupma, you are audible.
Yes, I'll share the screen, sir. Hello,
Yes.
my screen is visible to you, sir.
Yes, ma'am. You can
Okay,
continue.
okay, thank you, madam. Good morning, all. I'm Anupama Itki. Here, I'm presenting my work on advances in passive cell balancing for 1 minute, sir. Good morning, all. Here I'm today to present my work on advances in passive cell balancing for electric vehicle battery management systems. 1 minute, sir. I'm unable to change the slides. This is going to be my presentation outline. To start with, we know that lithium-ion batteries are inevitable part of electric vehicles. As we go on using these batteries in the electric vehicles, fire hazards and reduced battery capacity is a quite common problem that the user faces. As one of the solution, cell balancing is going to be discussed in this presentation today. Search strategy and databases. The work actually is carried out in four phases. First is selection of the databases. I have used IEEE, Springer, Wiley, and so on databases to collect the articles. Then the keywords which are used to search the articles.
Anupama ma'am, sorry for
Yes,
interruption.
yes, ma'am.
But have you changed your slide? Because still I can see only the title slide.
Yes, ma'am. I'm in slide number 2 now. Shall I share it again, ma'am? Shall I unshare and share it again?
Yeah, that will be better because I
Yes,
can
ma'am.
see only title slide right
Yes, ma'am.
now.
Yes, ma'am. Yes, ma'am. Now, ma'am. Hello.
Yes, now I can see search strategy and
Yes,
databases.
ma'am. Yes, ma'am. Shall I continue from here, ma'am?
Yes.
So the keywords used to get the articles to name few are resistive cell balancing, EV battery balancing, battery equalization, lithium ion cell balancing. So like this few keywords were used, and the articles spanning from 2020 to 2025 are considered to carry out the work. So after collecting the articles, screening criteria was set to know what articles to include and what articles to exclude. So, inclusion criteria basically consisted of reviewed articles which are focusing on passive cell balancing for EV application. So, active or hybrid cell balancing approaches and duplicate studies were excluded. The cell before understanding what are the causes of cell balancing, let me briefly tell you all what is cell balancing. So cell balancing is a process wherein the cells of the voltages or the SOC of the cells, whenever they are unequal, it is a process wherein they are tried to make equal, meaning the cell voltages are made equal, the cell SOCs are tried to equalize. So the basic reasons for cell imbalances are manufacturing variations, internal resistance mismatch between the cells, the temperature differences of the cell, and uneven aging of the cells. So, what is the need of cell balancing? So, whenever cell imbalance occurs, there are some hazardous situations that the user uh, has to uh, has to face, like fire hazards, lowered capacity availability of the battery, and all. And hence, there is a need of cell balancing to prevent overcharging of the individual cells, to reduce risk of over discharge of the weaker cells, to enhance the safety and life cycle of the cells, and also to improve the reliability and performance of the BMS. One thing that is to be noted here is whenever we have an imbalance occurring in the battery pack, which consists of cells connected in series, then the weak cell is always going to decide the overall capacity of the battery pack. Weak cell is that wherein which consists of lesser value of voltage, or it is that cell which has lesser SOC. We have two types of cell balancing techniques. First is active, wherein redistribution of the energy from higher voltage cell to lower voltage cell takes place with the help of converters or switches. Passive cell balancing is that a technique whereas excess energy which is present in the high voltage cell is dissipated through resistors which are connected across each cell. This is among these, point worth noting is among active and passive cell balancing. Passive cell balancing is the one which is commonly used in industries for EV application. Hence, the study is going to be focused more on passive cell balancing. This is a comparative study of passive cell balancing topologies that are available in the literature. First is fixed shunt resistor, wherein it is a simple design, cost effective. But the demerit is that there is going to be a continuous energy loss and the operation is uncontrolled. It is basically used for nickel and lead acid cells. So, to overcome the limitations of a fixed shunt resistor, switched shunt resistor topology was introduced, which has a lower complex controller. The demerits are the energy loss is going to be significant whenever the balancing currents are high, and it also demands a more number of components when compared to the previous topology. Applications are this passive cell balancing topology is basically used for low power applications also, and also it is compatible for lithium ion batteries. Next topology what we have is variable shunt register. So the in above both methods what we discussed, the resistor that we connect across the cell is always a fixed resistor. Whereas in this case where we have variable shunt resistor, whatever register we connect across the cell is can be varied, and this is the greatest advantage that we have, and hence it is applicable for both the slow and fast charging of the batteries. But the limitation is that it uses more number of registers when compared to the previous two cases. It is also compatible for lithium ion batteries. These are the circuit topologies for fixed shunt resistor, switched shunt resistor. In case of switched shunt resistor, we have a switch which is going to decide when, for what interval of time, my resistor should come across the cell. This is a variable switched shunt resistor. So here we have a few resistors connected in a parallel via switches. How many resistors are to be brought across the cell is going to be decided by the balancing current required, or it can be decided based on the balancing time. So advances in passive cell balancing, when I went through the literature, I could see that the work whatever is carried on till now till on passive cell balancing can be broadly classified into design trends, controller developments, hardware innovations, intelligent techniques, and work explicitly meant to enhance performance and safety. First one, design trends. Here researchers have tried using integrated ICs to balance the cells using passive cell balancing technique. Uh, scalable Scalable BMS designs, centralized and distributed passive BMS topologies are also discussed in the literature. Then the second one is controller development. Controller plays an important role when it comes to performance of the cell balancing circuit. Researchers have tried developing a controller with a adaptive threshold, and controllers are also designed using PI and NNN and ANN, and a comparative study is also uh, discussed in the literature. Hardware innovations. So, what we saw previously, that a resistor can be used across the cell in the process of cell balancing. So researchers have tried replacing that resistor by MOS. So the MOS operating in linear region so that it can be used as a resistor to dissipate the excess energy in the process of cell balancing. And then intelligent techniques.
Anupma, you have one
Yes,
minute to conclude your
yes,
presentation.
sir. Yes, sir. And intelligent techniques, machine learning assisted register selection is also been seen in the literature. Performance and safety, lot of work is also done to reduce the heat that gets generated and also to increase the balancing time. So research gaps identified are thermal management is the area wherein a work is to be carried out, and data driven passive balancing, the use of ml ai is less in passive cell balancing area, and hence work can be carried out using data driven techniques. And fault monitoring and balancing are done separately, so integration of these can also be a potential research area. Conclusion: passive cell balancing is widely used in EV application. The motivation for this work is the lack of comprehensive review on passive cell balancing. This work basically summarizes passive cell balancing methods, including their significance and circuit topologies. Potential research gaps are also discussed to enhance the working of passive cell balancing circuits. These are the references. Thank you.
Thank you for your presentation. Ma'am, do you have any questions?
Yes. So, Anupama ma'am,
Yes, ma'am.
whatever limitations you have identified for
Yes,
this
ma'am.
passive cell balancing through literature survey, so
Yes,
how these limitations impact battery safety and performance in electric vehicles?
yes, ma'am. First thing is thermal management. So, temperature of the battery has its own role to play in the safety and performance of the battery, because as the temperature is a major influencer on the internal resistance of the battery. So as the temperature increases, the internal resistance of the battery also increases, which leads to more voltage drop and also reduced usage available capacity of the battery. This is one thing. Then data driven passive balancing is that nowadays whatever work I have read basically says when imbalance occurs, this is what is going to be done. But hardly I have seen any work wherein imbalance is predicted beforehand and required control actions are initiated. So that is where I think data driven techniques can be used in the process of passive cell balancing. Then fault monitoring, faults like overcharging or over discharging of the battery are not good for the health of the battery. So these are monitored separately, but these are also responsible for the cell imbalance, and cell imbalance is not good for the life of the battery. It is going to reduce the capacity and also the life of the battery. So combining these two definitely is a good potential research area, I feel, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you. And next we have Rosa, paper titled Blood Group Prediction Using Fingerprint Image with MobiNet V2.
Good morning, sir. Sir, am I audible?
Yes, Rosa, you are audible.
Yes, sir. Let me share the screen. Good morning, one and all present here. My name is Roja HS from Department of Computer Science and Engineering, Maharaja Institute of Technology, Tandavapura. Today, I am going to present our research work on blood group prediction using fingerprint images with MobileNet V2. Our team members are Amulya YV, Rakshita S, Roja HS and Harshita HA under our mentor guidance, Suma HC. Let me tell you the abstract of our paper. Uh, as we know, As we know, blood group identification is a critical requirement in healthcare, especially during the blood transfusions, surgeries, and in emergency situations. Blood Traditional blood group identification methods require sample collection and laboratory testing. These are time consuming and resource intensive process. So in this work, we are proposing a fingerprint based blood group detection using deep learning techniques. We can use MobileNet V2 architecture. We used MobileNet V2 to analyze fingerprint images and classify them into blood groups. Uh, Here in this experiment, the result shows that deep learning models can effectively learn fingerprint patterns and provide accurate results. Blood group information plays a vital role in medical diagnosis and healthcare also. So any delay in identifying the correct blood group can result some serious implications for patients. Although traditional blood tests are reliable, they require laboratory infrastructure and trained personnel. With recent advancements in deep learning and biomedical imaging, biometric data such as fingerprints can be analyzed for healthcare applications. In our work, it is the intersection of fingerprint images and deep learning. We aims to achieve a alternative for blood group identification. This is the literature survey. Uh, we mainly considered two papers for that. This slide explains the problem statement. Traditional blood group identification methods requires blood samples, laboratory equipments, and trained personnel. This makes the process time consuming and difficult to use in emergency situations. So there is a need for faster and non-invasive and reliable method to identify a person's blood group. So the goal of this project is to develop a model that predicts the blood group using fingerprint images instead of blood tests using laboratory. The objective of our work is, first it will collect the fingerprint images, maybe using the scanner or images. Training images are given using data sets, and to apply the deep learning techniques for accurate blood group predictions. In deep learning technique, we used CNN, that is MobileNet V2, and to reduce the time required for the blood group identification and to support the emergency and medical situations where rapid decision making is required. So I said we used MobileNet V2. This is the flowchart how MobileNet V2 works. First, we collect the fingerprint images. To collect the fingerprint images, we use the open source, that is Kaggle. From Kaggle, we collected the fingerprint images. From Kaggle, we collected the fingerprint images. Next, pre-processing is performed to enhance the image quality. This includes resizing, normalization, and noise removal so that the fingerprint image is suitable for the analysis. Next, after pre-processing, feature extraction can be done using MobileNet V2. The model automatically learns important features of the fingerprint such as ridge patterns, loops, and texture formation. The extracted features are then passed to the fully connected layer, which prepares the data for classification. At last, the softmax classifier converts the output into probability values for each blood groups. Based on that, the blood group of the person can be detected. So this is the proposed methods. The same steps we have followed there. And same at first, we take the fingerprint image. It can be taken from the scanner or from training. We use the data set which is taken from the open source Kaggle. Next, we pre-process the image, that is noise removal, normalization, and we resize the image into 224 cross 224 pixels, as all the images should be in the same size so that it will be easy for MobileNet V2 to extract the features. Next, in MobileNet V2, it extract the fingerprint features. and at the output the softmax layer will predict the output. The results of our experiment can be seen in the confusion matrix. Um, Confusion matrix is used to evaluate the classification performance of the model. It compares the actual blood groups with the predicted blood groups. High values present in the diagonals indicate the correct predictions here, and the non-diagonal values represent the misclassification. This matrix helps us to understand how well the model performs across different blood groups. So this is the chart for the accuracy result. We achieved 94% of training accuracy and 90% of validation accuracy. I would like to conclude by saying that our work demonstrates that fingerprint based blood group detection is a feasible and non invasive method. This reduces the dependency on traditional blood tests. It provides a faster and efficient approach for blood group identification. These systems can be useful in emergency situations. Thank you.
Okay, Roja, so what do you think? What are the key limitations of using this fingerprint images for a blood group classification in real world emergency scenario, like particularly in terms of accuracy, reliability, and false predictions?
Ma'am, can you please repeat the
Yes. What are the key limitations of using this fingerprint images for blood group classification, which you have demonstrated? Actually, in terms real words, emergency scenario, particularly in terms of accuracy, reliability, as well as false predictions.
Yes, ma'am. The traditional methods give the reliable output, and the medical field it requires accurate output. But considering fingerprint, it is unique for each individual. We are only considering the common features, and we are achieving 94% of accuracy. But in medical fields, 100% accuracy is mandatory because uh, one mistake can lead to many complications, ma'am.
And how does this mobile net V2 based approach, which you have selected, compare with other deep learning architectures in terms of its efficiency as well as performance?
Yes, ma'am. There are other CNN deep learning models like ResNet and VGG16, but MobileNet V2 is lightweight model. Means it takes less memory and less computational power, and it can work in mobiles also. So as it takes less computational power and memory space.
Okay, thank you.
Thank you, ma'am.
Thank you for your presentation. And next we have Srushti, paper titled CNN Enhanced Compressed Sensing for Image Reconstruction Using OMP EchoSAMP.
Yes, sir. I'll share my screen.
Okay.
Is my screen visible?
Yes.
Excuse. Yeah. Okay. I'll start. So, good morning, everyone. Respected session chair, honorable panel members, distinguished researchers, and fellow delegates. I'm Srishti Siddhareddy, a postgraduate student from Department of Electronics and Communication Engineering, RV College of Engineering, Bangalore. Today, I am presenting our research work entitled CNN Enhanced Compressed Sensing for Image Reconstruction using OMP and COSAP. This work focuses on improving reconstruction accuracy in noisy environments by integrating compressed sensing algorithms with deep learning techniques, specifically convolutional neural networks, that is CNN. In modern wireless communication systems such as 5G, massive MIMO, and future 6G networks, accurate signal reconstruction and channel estimation play a critical role in ensuring reliable communication. Wireless channels are inherently sparse, which makes compressed sensing techniques highly suitable for channel estimation and signal recovery. Algorithms like OMP and COSAMP, that is compressive sampling matching pursuit, are widely used due to their ability to exploit sparsity and reduce sampling requirements. However, a major limitation of these algorithms is their performance degradation in low and moderate SNR conditions, where noise significantly affects reconstruction accuracy. To overcome this limitation, our work proposes integrating convolutional neural network with OMP and COSAMP to enhance robustness and improve reconstruction quality under noisy conditions. The literature survey reveals that the extensive research has been conducted on OMP and COSAMP individually for sparse signal recovery and channel estimation. As you can see, several studies have also explored use of deep learning, particularly CNNs, for denoising and image reconstruction tasks. However, I have seen that most existing works treat compressed sensing and deep learning as separate approaches. So very limited research explores the hybrid integration and compressed sensing algorithms with CNN, and even fewer works provide a comparative performance analysis across multiple SNR levels. This lack of integrated and comparative studies forms the motivation of our proposed work. Based on the literature survey, the following research gaps were identified. First, the lack of hybrid frameworks that integrates OMP and COSAMP with CNN-based refinement. Second, most students do not provide studies do not provide a systematic NMSC versus SNR comparison under identical condition. Third is robustness analysis under noisy environment is often insufficient. Our work addresses these gaps by proposing the comparing four reconstruction models, that is OMP, COSAMP, OMP with CNN and COSAMP with CNN under the same simulation setup. The objectives of this research are clearly defined. The first is to implement OMP and COSAMP algorithm for compressed sensing based reconstruction. Second, to integrate CNN based enhance with these algorithms to improve accuracy. Third, to evaluate and compare performance using normalized mean square error and peak signal to noise ratio. Finally, to analyze reconstruction quality using plots, reconstructed images, and bar charts. The methodology brings with loading a grayscale image which is used as a representative sparse signal. The signal is resized to a fixed dimension, normalized for numerical stability, and converted into one-dimensional vector to match the compressed sensing framework. To simulate realistic wireless condition, additive Gaussian noise is added at different SNR levels that are 5, 10, 15, and 20 dB, representing low to high noise environments. The reconstruction is then performed using OMP and COSAMP algorithms. To further improve reconstruction accuracy, a convolutional neural network is applied as a post-processing refinement stage. The CNN learns to suppress residual noise, and correct reconstruction errors, resulting in OMP plus CNN and COSAM plus CNN models. Performance is evaluated using NMSC for numerical accuracy and PSNR for visual quality, and results are visualized using curves, images, and bar charts. So these are the obtained results. The first result compares the OMP and COSAMP in terms of NMSC versus SNR. Across all SNR levels, you can see COSAMP consistently achieves lower NMSC than OMP, indicating superior reconstruction accuracy. This is due to COSAM's ability to select multiple atoms and perform pruning, making it more robust to noise. The second result compares OMP and OMP enhanced with CNN. So the OMP plus CNN model shows a clear reduction in NMSC, particularly at medium and high SNR levels. That demonstrates that the CNN effectively refines OMP sparse estimates by reducing noise and reconstruction. The third result shows that is COSAMP versus COSAMP with CNN. This CNN enhanced COSAMP consistently outperforms standard COSAMP across all SNR values. The improvement is especially noticeable at higher SNR, highlighting CNN's ability to enhance already good sparse estimates. The fourth result compares OMP plus CNN and COSAM plus CNN. Among the two CNN enhanced models, COSAM plus CNN achieves the lowest NMSC, confirming that combining a stronger sparse recovery algorithm with CNN refinement provides the best overall performance. This slide focuses on visual reconstruction quality. So at 5 dB SNR, the reconstructed image is heavily corrupted by noise and object details are barely visible. As SNR increases from 10, 15 and 20 dB, image clarity improve significantly and structural details become more recognizable. PSNR values increases steadily with SNR, ranging from approximately 15 dB at low SNR to 30 dB at high SNR, confirming improved visual quality and reduced distortion. So this is the bar chart provides a consolidated comparison of all four methods at selected SNR levels. CNN enhanced methods consistently shows lower NMSC values compared to their convolution counterparts. The performance gain is most prominent at low SNR where noise impact is high. Overall, COSAM plus CNN achieves the best reconstruction accuracy amongst the all methods. The real-time applications. This proposed framework is highly relevant for 5G and 6G wireless systems where accurate channel estimation is essential for reliable communication. It is particularly useful in massive MIMO systems where channels are sparse and noise sensitive. Additionally, the applications such as autonomous vehicles, V2X communication, military and disaster response networks benefits from robustness of the proposed approach under harsh and noisy conditions. To conclude, the proposed hybrid OMP COSAMP CNN framework delivers clear quantity improvements. At low SNR levels of 0 to 5 dB, it achieves 20 to 25% reduction in NMSC, demonstrating strong robustness under noisy conditions. At moderate to high SNR values between 10 to 20 dB, the NMSC reduction increases to 30 to 40%, confirming superior channel reconstruction accuracy. Moreover, the framework converges faster with fewer iterations, resulting in lower computational complexity. Overall, these results validate the effectiveness of the proposed approach for 5G and beyond wireless channel estimation. The future work can extend this framework to real wireless channel data and multi-user massive MIMO systems. More advanced deep learning models such as deep CNNs, residual networks, or transformer-based architectures can be explored. The approach can also be optimized for real-time and edge deployment. and extended to joint channel estimation and beamforming, as well as video and hyperspectral image reconstruction. Thank you for your time and attention.
Thank you for your presentation. Ma'am, do you have any questions?
Uh, yes. So, as per the first graph that you have shown,
Yes, ma'am.
what characteristics of COSAMP algorithm contribute to its consistently lower NMSE compared to OMP, and particularly under this low SNR conditions?
Like, because COSAMP actually the iterations are less, and it is also known as greedy algorithm. So it like the iteration is done as like one dominant atom per iteration. Like every time it takes only one part of the image, that is one pixel, then it iterates and goes to the next pixel. So based on that, COSAMP is more reliable, and yeah, in OMP it just checks like it's just see what is the image and gives the output.
Okay, and what are the computational trade-offs introduced by CNN enhanced hybrid approach?
Can you repeat, ma'am?
Uh, what are the computational trade-offs introduced by this CNN enhanced hybrid approach? Maybe in terms of reconstruction time or scalability
Yes,
or
ma'am. Yeah, it improves estimation accuracy, ma'am. It is on accuracy and additional computational cost. Like, as like in CNN, the training and interference is low. Like, no need of much training is done in CNN, whereas in other computation, whereas in COSAMP and OMP, we need to do more training work. And once the training is done, it is relatively fast and efficiently implemented you in parallelly in hardware also.
okay. Thank you.
Thank you, ma'am.
Next, we have Superkan, paper titled Content-Based AI Recommendation System for Discovering Research-Related Journals for Engineering Students.
Hello, am I audible?
Yes, you are audible.
Okay.
You may please begin with your presentation.
Okay. Hi, I am Supakan, and today I am going to present my paper, which is a survey about content-based AI recommendation system for discovering research-related journal for engineering students. As for the agenda, I will go over the introduction, literature reviews, methodologies, result and discussion, and then conclusion. As for the introduction, higher educational level students have to do a lot of research, and one of the most important steps is to find relevant source to read and also use as related work or citation. With so many publications published every year, casual searching is not enough. It takes so much time, and we may not get the one that is just right. So here come the content-based system, which use the semantic similarity, which have been proven to outperform the traditional methods in terms of relevance and overall satisfaction, as it not only analyzed the surface level keywords, but also considered the latent meaning of the documents, ensuring that the papers align more closely with the author intention. Therefore, the research proceeds with the evaluating feedback from engineering students who have used the content-based recommendation before and used the numerical analysis to determine their perceptions, then convert it into a chart to explore more insight. For the literature review, I will briefly go over four methods. The first two are what we often see in e-commerce and media platform. Collaborative filtering group users based on the similarity and then suggest a result that match those with shared preference. And the big advantage is the novelty, as it can recommend things that we did not even know it exists by simply looking at the group behavior. But if there is not enough history, the result can feel off. For the popularity base, It looks at what is trending and suggests them. The upside is it does not need any personal history, but it may lack personalization. Like we might end up with suggestions that are technically popular but no longer relevant. The heuristic base relies on decision logic, like ranking strategies. The big advantage is that it is lightweight, easy to understand and implement, since the rules are explicit. But the downside is that it can become outdated because it does not adapt over time. The content-based analyze the semantic information like keywords, abstracts, or metadata and match that with a user's past behavior. It is widely used in academic domains as it can deliver effective results without relying heavily on user interaction or other users' data. But the challenge is the feature engineering, as pre-processing can be computationally extensive. And to improve the relevance, the CBRS are often combined with other methods like descriptive analytics, making them useful in fields where interpretations matters, such as academic, medicine, or entertainment. As for the methodologies, the simple CBRS consists of 4 components: a recommender to implement with machine learning library, a collection of journals, a DB to store users' preference, and a UI. For these studies, we want to evaluate how engineering students perceive a CBRS compared to the traditional approach, so we designed a quantitative survey with 15 questions, each rated on a scale of 1 to 5, then performed the statistical analysis. And we used the purposive sampling to pick students who have used the system before, and our data collection process do follow the ethical guidelines, as no personal information was collected and participants were voluntarily. Now, let's move on with the result. We collect a total of 90 varied responses through Google Forms. Among them, 57 were UT, 31 were PT, and 2 were PhD. We have divided the findings into 4 groups. The first group is the content quality. Overall, the students found the recommendation moderately helpful in locating the relevant source, with a mean score of 3.59. Even with varied opinion of the standard deviation of 1.15, for the literature review support, the perception was slightly higher, with the mean of 3.66. However, when it comes to novelty, the system was seen as less impressive, scoring only 3.32. As for the clarity and usefulness for citation, the results were again moderate. The clarity scored 3.52, while the usefulness for citation was slightly lower at 3.49. Next, let's look at the system performance group. Overall, the students were generally satisfied with the timeliness of the recommendation, as reflected in the mean score of 3.63. But when it came to personalization and content diversity, the rating were often moderate, with a mean score of 3.56 and 3.59, respectively. For the system interface and trust, the UI was deemed as user-friendly, with the mean score of 3.74. However, when it comes to trust, the responses were more moderate, with the means of 3.47, indicating room for improvement. For user engagement and satisfaction, the feedback here was very positive. The intention to use the system again received the highest score of 3.92, with the standard deviation of 0.89. Close behind was overall user satisfaction, which scored 3.90 and the same standard deviation. Other factors such as explanation clarity, research state alignment, and topic discovery were also rated positively, with each has the mean score of at least 3.7 and SD under 1, meaning students not only find the system useful, but also willing to continue using it in their academic work. Finally, let's look at how different educational levels perceive the 15 dimension. Even though the opinions are varied since they're standard deviation ranging between 0.73 and 1.27, some pattern emerged. The PG and PhD scholar consistently gave higher ratings compared to UT students. For example, explanation clarity scored 3.94 for PG, while UT gave it lower at 3.58. Similarly, for citation usefulness, it was rated 3.71 by PG compared to UG that is only 3.35. This difference may reflect the academic maturity, as the PG and PhD students often have stronger foundational knowledge and are more familiar with research terminology, which helps them grasp the details more easily, while UG, on the other hand, may need more explicit explanation. Other aspects also showed significantly higher ratings among the postgrad. This topic discovery, which is 3.84 versus 3.65, research state alignment, navigation ease, personalization, accessible quality, and literature review support and relevance. So overall, this finding suggests that PG and PhD students not only rate the system more positively, but also benefit more from its features compared to UG students. So in conclusion, the system appears to meet the core expectation of the user with a mean score of 3.90 and is perceived as beneficial and demonstrate the potential to be repeatedly used with students' ongoing work, as there is a higher score of 3.92. And the high ratings mean score in the ease of navigation, explanation quality, and topic discovery, also with the alignment with research state, indicate that the system usability may compensate for the limitation on the other areas. And this area tell whether the further development should be prioritized by the developers, especially to ensure the accessibility, personalization, and refinement for the model to surface more emerging innovative technology for novelty. And that is all for my presentation. Thank you very much.
Thank you for your presentation. Ma'am, do you have any questions?
Yes. So as per your conclusion, do you feel that 90 survey responses are good and sufficient?
Personally, I think since we have over 50, almost 60 for UG and 30 something for PG, it is quite sufficient, but we actually lack the responder from PhD scholars since there are only two. If possible, I would like to continue this research in the future and get more response so I can get the more accurate result.
Okay. And how does this proposed recommendation system compare with collaborative or hybrid recommendation approaches, maybe in terms of personalization and topic discovery?
Yes, if we combine it with other systems, for example, descriptive analytics, or even with CF, we can even get more personalization and more flexibility in finding emerging results. And even if we lack some information or historical information, it can still recommend something that is more relevant to the users.
Okay, thank you.
Thank you, ma'am.
So next we have Medela, paper titled Driving Factor Behind Occupational Health Challenges Among Handloom Weavers.
Good morning, all. Good morning, sir. Good morning, ma'am. Can you see the presentation?
Your screen was not visible. Can you please share the screen?
Just a minute, sir. Share screen. Now, can you see, sir?
Yes, it is visible now. You may please begin with your presentation.
Good morning, all. This is Mohit. I'm from Amrita School of Business, Coimbatore. I'm here to present on driving factors behind occupational health challenges among handloom weavers. So, firstly, I would like to start the motivation behind me doing this particular thing is that I, coming from a handloom weaver's business background, I have observed a problem that there is a drop in number of handloom weavers community in the recent days. So it built the curiosity of me that what would be the factors that are causing to this reduced number. So uh, I tried doing some research on this. So I have found there are few factors that are influencing their occupational health, that are bringing them a long term health challenges. So we have identified few factors which are complex, and they are contributing to this occupational health challenges, and we have analyzed the relation between each other. So that weaving being one of the vital sector of the nation, being the second largest rural employer after agriculture, like there are around 43 lakh workers in this. So many rural communities these days are continuing in this producing silk and handcrafts, and also this handloom sector. So health is a fundamental for every work professional, so which needs an improved governance and mitigate risks of enhancing their insurance covers on maintaining their well-being in this particular sector. So there is also these traditional weaving methods where you can see the handloom weavers. There is a lot of manual movement that is being there, and they are being exposed to a lot of chemicals and the lint and dust that is being produced in that particular thing. And this continuous muscular strain is causing their effects in the body, which are causing them a lot of health challenges. So prior studies just explore the specific issue like the workstation design and all. There is no integrated study. So that is where we found the gap to make a multidimensional study integrating ergonomic, chemical, and socio-financial drivers influencing their occupational health. So we are using a GINA analysis, which is the Grace Influence Analysis, as a methodology for doing this research work. So initially, we have identified the factors which are making a significant influence on their occupational health. From that literature, we have come to a conclusion to analyze on these 7 factors and relation between each other, and how one factor is influencing the remaining other factors. So, going through the methodology, as I have stated, we have analyzed the Grace Influence tool to make this. So, we have collected data from the respondents after identifying the factors. We have collected data from around 26 respondents, where we have, after filtered it down to 19 to mitigate the bias that is caused with few outlier responses. And we have followed this particular methodology where after obtaining the data, we have sorted and cleaned it and converted into grayscale, where initially we have taken the data in Likert scale, like from very high to very low in a 5 scale. So after that, we have converted into grayscale into the numbers like 1 2 3 4 5. So after this, let's go to discussions, and I'll just explain you in detail. So after this, we have made this into a whitened data to have a actual analysis, and also to show the even more accurate data. So the first thing you have seen is critical. This is a direct response sum that we have taken, like respondents sum, where each factor is influencing one another. Like the factor 1, you can see, is influencing 2 3 4 5 6 and 7, and 2 is going for 1 3 4 5 6 7, and so on. So the first thing is the initial response, and the ideal response is where the maximum that it can be achieved, like the maximum efficiency that can be achieved. So the typical thing is where we can achieve in between. So you know that system cannot be ideal at any point of time. So the typical thing is what is planned to be achieved. So this is the segregation of the factors that are influencing, where you can see the aggregate responses of the data that we have got from the respondents. So this table represents the total influence, where we have taken influence coefficient as well as the respective coefficients as well. So here this represents like the influence coefficient is how each factor is influencing the other factor, like change in A is how the change in A is influencing B, C, D, and E, and so on. So when you go to GRC, it is the trend across the data. Like for factor 1, we can see how are the respondents giving their response in terms of this factor, and how that trend is changing across the multiple respondents. So you can see the total influence, where it is the sum of GIC and GRC. So after which we have found that PEC, which is the prolonged ergonomic strain, and CEDT, which is the chemical exposure from dust and treatments, is the two most influential factors. So these are the top two most influential drivers that show a strong influence on occupational health challenges. So PES showing the highest centrality, like GIC and GRC, which indicates that both influence and is multiple other drivers. It is influencing the multiple other drivers a lot. So CEDT has the highest GIC but lower GRC, indicating it operates more as cost driver, but pushing the system change to other respondents as well. This is the conclusions that I have got. So PEC and CEDT jointly intensify the ergonomic, chemical, and respiratory burdens, which is creating a challenge in the healthcare system. So these factors significantly affect FCNJ, which is financial constraints. So through reduced output and absenteeism and job insecurity. So PES increases barriers to LAOH, which is limited access to occupational health, which is another factor that is being influenced by PES a lot. So together, these shape cause and effect pathways, and these consequences making them the primary intervention targets for reduced occupational health challenges. So the limitations of this being these are taken only from the perspective of a handloom weaver, and this research is based on identified factors from the literature, and the causal relations are identified in between these 7 factors using gene analysis. So there are a few other methodologies which can be conducted based on the interpretive structural modeling, which also explores comparative results on more than the gene analysis. So we have also taken a small sample size to compare in this methodology, because this is just starting of the multidimensional approach for this handloom occupational health challenges. So that being the limitations, I would like to conclude the implications from the study. So this highlights the urgent need for stringent occupational safety standards for handloom sector, and emphasizes on strengthening the primary healthcare centers and daily checkups, and also give some health checkups, and advise them to get trainings on the posture and all the workstation ergonomics, make some changes, and promote the natural dyes, which can reduce their exposure to chemical dyes. That's it from my side. So this future scope and this extends to research, where I have said we can compare it with socioeconomic and demographics, like gender, income, and also it depends on their availability of healthcare facilities nearby them, and exploring technological, behavioral, and psychological social dimensions of ergonomic inventions in this sector can also be extended as the future work. So thank you. These are the references that I have used. So thank you. Any questions?
Thank you for your presentation. Ma'am, do you have any
Yes.
questions?
Yes. So some different topic you have come up with. I don't know whether you told in your presentation or I missed it, but which sector is studied in this research?
Ma'am, handloom weaver sector, ma'am.
No, but like which area I'm talking about area, specific area. Have you considered?
Ma'am, can you be a little specific on area kind? What or does that mean?
Regional area I'm talking about.
Yes, ma'am. It was a, regional area itself, ma'am. Like where I have come from a background, as I said, from a handloom business background. So I have considered Sri Kalahasti as the region, my hometown, where I could be able to interact with the viewers directly and get their feedback and the responses.
Okay. And
Yes.
as you said, like there are different countries you have named where this handloom weavers business is going on. So have you done any kind of statistical analysis, like for which country having maximum kind of handloom weavers?
Ma'am, generally, India is having the highest handloom weavers. From a study where I have seen, it is a study in 2010 around, ma'am. But currently, there is no study that is stating that India is highest. As we can see, like a significant drop in the number. Currently, there is no study that is there where we can state that this country is on top.
Okay. And what do you think, which factors or which factor is linked to dyeing and this chemical use?
Ma'am, when dyeing, there is a lot of chemicals that are being used. Example like caustic soda and all. So these chemicals emit harmful gases, which being for a long time exposure for these can cause their breathing problems, lung problems, and many other diseases like eye irritations and skin rash and many other things. And you can see that chemical dyes that are being used for colors. So that when applied on the skin might cause uh, what skin irritations when being exposed for long times, ma'am.
Okay. Thank
Yeah.
you.
Thank you, ma'am.
And then next we have Mohammad Rifan, paper titled Implementation of AI ML based model for predicting agri horticultural commodity price for pulses and vegetables.
Hello, sir.
Hello. You may please begin with your presentation.
Sir, there is a slight change in the name. The presenter is Nidhi VR.
Okay.
Okay, sir. I'll be sharing my screens. Good morning, everyone. I am Nidhi VR from ADME College of Engineering, Mysuru. I am presenting our paper titled Implementation of AI ML based models for predicting agri horticultural commodity prices for pulses and vegetables. This paper is done under the guidance of Yogesh and ATME College of Engineering, Mysuru. Coming to the abstract, this paper presents a web-based machine learning system designed to predict prices of agri-horticultural commodities such as pulses, vegetables, and fruits in Karnataka. This system predicts monthly prices for both short-term and long-term periods. Among the evaluated models, Random Forest delivered the best performance and was deployed using Streamlit for easy access. Introduction. Agriculture plays a crucial role in Karnataka's economy. However, commodity prices fluctuate frequently due to factors like weather, demand, and market uncertainty. The goal is to develop a region specific predictive platform covering 37 commodities across 10 regions, support informed decision making. The problem statement is that the currently most price forecasting approaches depend on manual reports or basic statistical models. These systems are often not real time. They lack regional specificity and do not provide a personalized forecast. Uh, Due to this, this creates a strong need for accurate, local, and accessible price prediction tools. The proposed system and objectives. We have implemented a web-based ML platform where user selects a region and commodity. The system generates 6-month and 12-month price forecast. The objective of our project or the paper is to improve the prediction accuracy and provide a user-friendly interface and support better decision making through visual analytics and downloadable predictions. In methodology, we collected data from government portals, open datasets, and web scraped market prices. Key features includes data, commodity, region, unit price, season, year, and month. Like data pre-processing involved cleaning, null removal, date formatting, outline handling, encoding, normalization. This step is ensured for high quality in input handling and model training. Next, we implemented the feature engineering. This includes the lag feature, such as previous month price and rolling averages to capture seasonality. For modeling, we trained a separate random forest regressor for each commodity using an 80-20 train test split. Model performances was evaluated on the basis of MAE, that is mean absolute error, RMSE, that is root mean square error, and R square. Next comes the system architecture and data flow diagram. This system allows a clear pipeline, that is first step is data collection, second is pre-processing, next comes feature engineering, next is model training, next comes the deployment. The streamlined front end allows users interactively selects input and visualize forecast. This architecture and data flow diagram shown here illustrate how data moves to each stage of the system, sir. Okay, next is the data flow diagram. This is the visual of how our paper model works. Implementation. In the part of implementation, we have used the Streamlit app which selects panels, forecast charts, analytics. The application is implemented using Streamlit, offering an interactive dashboard. Users can select crops, regions, and time periods and view forecast charts, analytical cards, and tables. Here, this interface supports market comparisons and makes insights easy, understandable, and not for non-technical users. Results. In the results part, the random forest what we have implemented achieved is mean, that is mean absolute error approximately rupees 3.07, mean, that is mean root square error, that is approximately 4.48, then mean R square, that is R square error approximately 90.6 across all commodities. Then visual comparison between actual time and predicted prices shows model comparison. Model captures seasonal and regional trends effectively. Conclusion. To conclude this work demonstrates that AI ML techniques combined with a web-based interface can deliver accurate region-specific price predictions. The system supports farmers, traders in planning and reducing market uncertainty. Future works include integrating climate factors, expanding to other states, and exploring deep learning models. Thank you.
Thank you for your presentation. Ma'am, do you have any questions?
Yes. So, Nidhishri,
Yes, ma'am.
this work you have proposed for Karnataka state, right?
Yes, ma'am.
So, if we change the state, what do you think? How it will affect accuracy, and where in your model we need to make the necessary changes?
Can you repeat once again, ma'am?
This work you have proposed for Karnataka
Yes, ma'am.
state, right?
Yes, ma'am.
If we change the state, like this proposed model we want to implement at some other state other than Karnataka.
Yes, ma'am.
So in your model, where you need to make the necessary changes, or whether this proposed same model will work for other state too.
No, ma'am. This will work for Karnataka state, where if we change the state, we need a different market prices according to their state. We need a different climate, where climate varies from region to region, from state to state. We need the state climate, rainfall, soil, those informations. So historical price data must be replaced or extended with new data of the new state if we are going to change.
Okay. And why you feel that like this or commodity price prediction is challenging?
Huh?
Why is this commodity price prediction is challenging?
Hello?
Yes. Have you understood the question?
Ma'am, is this audible?
Yes.
It is because of manual. There are fluctuations of weather, demand.
Okay. Thank you.
Thank you.
So next we have Kirti Sikka, Insura AI, transforming insurance workflow through agentic AI.
Good morning. Am I audible?
Yes, you are audible. You may please begin with your presentation.
Yeah, I hope the presentation is visible.
Yes, it
Hello.
is.
Okay. So, good morning. I am Kirti Sikka from CSC AI, studying in Amrita Vishwa Vidyapeetham. And today I'll be presenting a research paper, Insura AI, Transforming Insurance Workflows Through Agentic AI, co-authored by Rishikesh G. Nair, Gayatri B. Nair, under the mentorship of our professor, Dr. Veena G. So, for introduction, we'll first see why it is important for us to talk about insurance as all. Insurance is something that everyone needs, be it a health insurance, be it a car insurance, or this is something that every user or every person requires it. So, there's a need for management of this. And when it comes to users who are not that much of technologically aware of it, it's harder for them to know about these insurances. And from the agent side of it, the people who are actually selling the insurances, they also need a proper management of handling all of the clients that they have, all of the policies that they have, and all of the users from it. So the problem is basically when we talk about insurance agent side, then the thing is whenever an insurance agent wants to handle a lot of clients, it also has different agents which are training under them, also the clients and also the policies, multiple policies of that particular client as well. So basically they have to handle a lot of forms, a lot of policy documents, a lot of claim processes, and a lot of manual paperwork. So we are proposing a platform which makes it easier for them to handle documents. So so basically there's a limited support when it comes to voice based or multimodal interaction. Basically if the user also wants to query on the documents they have, also the agent also wants to query about the client and the policy documents that it is being stored. So a platform wherein the agent can also manage the number of clients it has, and also the users, which can also query on their own particular policies or anything that they want to buy, be it car insurance, be it health insurance, be it anything. So the existing systems that we have right now and the research gaps that we found were, so whatever papers and literature review that we did, so they are mainly focusing on like general question and answers. So basically you can query what is the health insurance in LIC or ICICI, but there is no specific policies that have been retrieved and the information which is given to us. Similarly, the agent specific is also not given. So if I'm putting some policy of some user and I want to query on that user's data specifically, that system doesn't exist. And one more thing which doesn't exist is voice based. So we want to make this easier for the users and the agent side of it as well. We want them to have a user accessibility. So a user can just like say what is the premium for this policy, just voice it, and then the LLM will just give the response to us. So that is the research gap that we are handling as well. So yeah, so proposed solution, first thing will be handling all of this using voice, and prompt as well as there, but voice is the mainly thing that we're handling. Then enhanced document handling, all the specific documents to users as well as agent will be handled using our system. Then also there will be a multi-agent system, which will basically is like if I'm asking a normal query not specific to my policy or not specific to my user data, then also I'll get answers to it. So the methodology. Yes. So methodology is basically if I'm a user, there can be two scenarios. I can be an agent or a user. So if I'm logging in as an agent, I'll select as agent, I'll upload the policy documents or claim documents of my clients or the agents which I've been handling. So during that, firstly, I can query after uploading or query the user like which all users have their premium due in next 10 days. So querying that will give me the results for that specific user. Then also there's a functionality that we have added which is unique and which doesn't exist in a lot of papers is a voice calling. So I could like whatever context, let's say I have following the same example, uh, premium for premium due in 5 days. So it'll give me a list of 4 to 5 clients. Their premium is due in 5 days. So what will model do is model take the context from the data stored, and that will be given to the voice agent that we are using, and the voice agent will call that particular user and resolve the queries and remind them to pay the premium to it, pay the premium. So how are we doing the data collection and what all data that we used to make this particular thing? We almost used due to security reasons, we couldn't use all like user-centric data. Some of them was synthetic data and some of it was our own data that we used to train it. So around synthetic data was like 300 images that we generated because for the policy documents, and wherein we focused on policy ID, the name, the type, dates of the premium, the nominees, and all of that was used. Using for this pre-processing and all, we used OCR to like extract all of the data to enhance the quality of it. Then for agentic workflow design, as I said previously as well, we have 3 main agents that we are taking about. So if a user, so basically we need to identify if the user is asking a query which is related to his or her own particular document in context or just a general query. So agent which distinguishing between those. So if it is a user, it'll go to a normal LLM which will generate the data according to that. And if it is a context-based query, it'll go to the RAG pipeline and give me the answer basis of that. And for RAG, we have fine-tuned the LLM model. We are using Tiny Llama for it, and we have fine-tuned that, and it'll give me the results according to that. We also have a memory manager, which is basically whenever we are doing RAG, we are storing the conversation or whatever conversation has been done, so that it's easier for the LLM to retrieve faster. Then for normal thing, we're using Llama, and for the fine tune, we're using Tiny Llama for specialized insurance Q&A, which is basically the context-based user queries. Okay, so after all of this, getting the data, after the voice has been also done, there's an also option for the agent to whatever data has been stored for user specific, like premium and all that. There's a facility for them to retrieve all of the data stored in CSV or like a Excel sheet so that it is easier for them to keep track as well. So the results of it, basically, we also tested various models according to it. First part was testing OCR models as well. So during that process, we actually selected parallel OCR. Then we moved on to Tiny Llama and Mistral 7B, which was fine-tuned on the data that we collected or synthetic data that we generated on it. So during that process, we moved to Tiny Llama as it was more domain specific and we didn't need that bigger of a model, Mr. 7B, because we're handling just a very specific problem, which is insurance documents centric to user. Then for voice integration and calling, we used Bland AI, which was just an API wherein we fine-tuned that thing using a sequence of prompts and integrated those API into our system. And using these things, we were able to achieve a higher accuracy and to make the system also low latency using text and voice inputs as well. So for concluding our website or project, I would say it is a system that that provides accessibility and easier for agent and users to query the data, for agents to keep track of the clients, for agents to call the users and remind them about premium as well. It reduces the manual workload which comes to the agents, and also it is helpful if the user is not from a technical background or not from an insurance background or is very new to something and new to the insurance field and just wants to query the data on it. Thank you.
Thank you for the presentation. Ma'am, do you have any questions?
Yes. So what are the limitations of Tiny Llama in terms of accuracy or latency?
Tiny Llama is actually a small model that we are using because of GPU constraints that we had. So uh, like it has fewer parameters that we use. Like we used a smaller model, 1 billion parameters, so it was a fewer model that we used, and it cannot handle like larger capacity of data set. And latency wise, it was like a little slower when it if we were using some other bigger models.
Okay. And how does Insura AI ensures the data security?
For data security, we are using authentication as of now. So whatever data that we are stored is in ChromaDB. So authentication is done using JWT session tokens. So whenever it is authenticating like that, the ChromaDB stores everything, and you cannot access the DB until unless you have the tokens or the authentication key that we have. So that is the only security.
Okay. Thank you.
Thank you.
So next we have Satish Rao, paper titled Smart Hybrid in Energy Meter.
Thank you, sir. Am I audible, sir?
Yes, you are audible. You may please begin with your presentation.
Yeah. Good morning, all. Myself, Satish. I'm presenting about smart hybrid energy meter. Coming to the introduction, India's current power supply system is unable to consistently deliver the necessary electricity.
Sorry for the interruption, but can you be please bit louder? Your voice is becoming very low.
Yeah, sure.
Yeah.
Due to the power grid inability to reach the locations, almost 0.4 billion people are inaccessible to the electricity. The power instability is another issue since the consumer load is fluctuating. The frequency is also varying due to the instability in the power generation. The presented system helps in monitoring the power usage and also helps in the load performance analysis and also helps in the dynamic billing. Based on the power consumption, optimization of the usage of the system is possible. Dynamic building will help in shifting the power consumption away from the peak hours to the non-peak hours. Therefore, we can improve the management of the electricity supply. The present challenges include manual reading of the meters, which causes delay and errors. The power instability, as mentioned earlier, it is due to the supply variation, which leads to the frequency variations due to the load imbalance. Power theft is another problem, and peak hour congestion and inefficient load management is also another problem which is faced by the present system. The proposed solution includes automated data collection and processing, and hence billing can be automated, and real-time power monitoring and alerts, power theft detection with load cutoff, hybrid, in the sense prepaid or postpaid billing system, and the cloud-based integration so that user can visualize the power usage. So this is the system architecture where basically we are making use of a microcontroller as a processing unit, and each junction box will have a power sensing system, uh, uh, and this data will be sent to the microcontroller through optocoupler, and the display which will display the power usage, and the relay system which will help in cutting off the power, RFID reader, which will help in the building system, switch array for detection of the switch array for selecting the different modes. The system has got three different modes, and also it uses Wi-Fi module through which the data is sent to the cloud. This system has three different operating modes. The first mode is the monitoring, second mode is the theft detection, third mode is the hybrid billing mode. The user can, based on the requirement, user can select any of the mode. The power detection methodology here in this system, what we have done is we have used AC current transformer from the electronic energy meter, and which will sense the power usage, and it will give out the data in the form of a pulses. There will be definite number of LED blinking per kilowatt. So this data is sensed, and through optocoupler it is sent to the microcontroller. The microcontroller will compute the energy computation, and it will display the data on the LC. So in mode one, what we do is the power consumed by a particular junction box is processed, and it will be displayed on the LCD display. And also this data is sent through Bluetooth. This data is also sent to the PC. And in the PC, we have developed an application using C#, where this data is, that is the power consumption data, is displayed using this particular application. And in second mode is basically power theft detection. So in this mode, the microcontroller is programmed so that if there is electricity theft, then it will be immediately detected and the power is cut off to that particular junction. And also along with this, consumer will be notified with the buzzer and also alert message on the application that is run on the PC. In the third mode, it is a hybrid mode where basically it concentrates on the billing. In this, we have prepaid mode as well as the postpaid. The RFID reader, which is a valid RFID card, and it reads the RFID card, and based on the balance available, it will start the electricity supply. And whenever balance goes low, the electricity supply is being cut off using the relay. Whereas in the postpaid mode, the power consumption data is continuously sent to the cloud, and which is done using the Wi-Fi model. The user can monitor the power usage data on the cloud, and also the dynamic billing can also be done based on the data stored in the cloud. The methodology used for the detection of power consumption by each junction. The energy meter circuitry is basically we have made user, which consists of ASIC and current transformer. So this data is sent to the microcontroller through optocoupler, and the computation of the power consumption in terms of kilowatt hour is computed, and it will be displayed. So for transferring the data from ASIC to the microcontroller, optocoupler is being used, which consists of LED and LDR module, and also a comparator which will generate necessary pulse to the microcontroller. Sending the data and storing the data from microcontroller to the PC is done using Bluetooth module. We have used HT05 module for sending the data continuously from the microcontroller to the PC. And Microsoft Access is being used for storing the data. And the application, that is a GUI, is developed using C# language. And Wi-Fi module ESP8266 is being used to connect the microcontroller to the ThinkSpeak cloud. The complete data, the meter reading, or the power consumed is stored in the ThinkSpeak cloud. And user with the valid login credentials can monitor how much of a unit of power they have consumed, along with real-time pricing. This is the developed prototype where we can see the STM microcontroller block over here. And we have one main junction box and two subjunctions, junction 1 and junction 2. The supply is coming to junction 1 and junction 2 from the main junction box. And here is a switch array which is used for selecting the mode. And there is a RFID module, LCD display, and Wi-Fi module over here. And we have used 3 different energy meter circuitry, 1, 2, and 3. 1 for the main junction box, remaining 2 are for subjunctions. This is the mode 1 where this is the mode selection, where one is optimization, power optimization. Second one is theft mode, and third one is hybrid mode. When mode 1 is selected, it will basically show each junction how much power is being consumed. So here we can see junction 1 has consumed 23 units of the power, and junction 2 is 18 units. And same is displayed on the PC application as well, with each junction's status. And suppose if mode 2 is selected, it is a power theft detection. Suppose if power theft is detected, then it will alert the user with the help of a buzzer, as well as the application will display the same on PC. And by this power theft is detected based on what is the power which is delivered by the main junction, and how much power is consumed in the subjunctions. This total is compared based on that power detections, detections. And in mode 3, we have two different modes. The latest
Satish, you have 1 minute to conclude your presentation.
Yes, yes. Prepaid mode and postpaid mode. If prepaid mode is selected, you can see in the second figure the user one, what is the balance left, and based on that, the billing, based on the balance, you can view the balance and you can consume the power. If balance goes to zero, then power will be cut. So this is the graphical representation of the data stored in the cloud. To conclude, the automated solution basically reduces the errors in the manual billing system, and it also addresses the major problems like billing related issues and non-information. It can be used in homes, industries, or integrate the system only. Future announcements include dynamic tariff implementation so that you can shift the peak hours loading can shift it to the off-peak hours and then optimization. AI-based anomaly detection and for power consumption patterns can also be done. These are the references. Thank you.
Thank you, Satish, for your presentation. Ma'am, do you have any questions?
Yes, so Satish, what measures are implemented to ensure reliable and secure wireless data transmission from your energy meter to the server using this Wi-Fi module?
Yeah, at present we have not concentrated on any encryption of the data since it was a protocol. In future, if this is continued, obviously we can go for any of the encryption techniques and that can be utilized in securely transmitting the data from the system to the either to the PC or to the cloud.
Okay, thank you.
Yeah, thank you.
So next we have Bindu S, paper titled Thyroid Cancer Detection Using MI. Next we have Shilpi Taneja, paper titled A Low-Code, No-Code Approach to Design Open Source AI-Powered Learning Assistant. So, I sincerely thank our author for their excellent presentation and contribution in this session, and all our participants for being a part for this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during this 10th version and all the 9 previous version of the conference. We will be happy to have you in 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. And now, I also thank our session chair, Dr. Rupali Mahesh Chopade, for chairing this session. A token of appreciation to the chair on behalf of Team ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Would you like to share a quick closing remark, ma'am?
Sure. So first of all, thank you organizing team for inviting me as a session chair for this session. Thank you all the presenters for your insightful and well prepared presentations, as well as audience for this wonderful audience, I can say. Uh, so thank you.
Thank you, ma'am. I kindly request you all to switch on the camera for a quick snapshot for the virtual conference. Stay safe and take care. Thank you.
Thank you, sir. Thank you, ma'am, for your time and patience.